Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over the graphs of parent functions. A parent function is the simplest form in a family of functions. For example, you can have a function that looks like f of x equals 3x squared plus 4x minus 2, or f of x equals negative x squared minus 4x plus 17. Both of these are in the family f of x equals x squared, so the parent function is f of x equals x squared. We can use parent function to find the shape of a function, whether it's even or odd, the domain and the range of the function, and the end behavior of a function. We can also use parent functions to graph transformations. First, let's look at a constant function. A constant function is a horizontal line at a point C. The function is f of x equals c. This is an even function. Even functions are symmetric across the y-axis. That means everything that's happening on the right side of the y-axis is going to be mirrored on the left side. So anytime we see a function that is identical on both right and left sides, it is even. Anytime we see a function that reflects across the line y equals negative x or across a diagonal line, that's going to be an odd function, and we'll see a couple examples of these later. But this function is even. The domain, or all possible x values, is negative infinity to infinity. The range is only one value, y equals c. So the range is all possible y values, and our only possible y value is y equals c. The end behavior is what our graph does at its end. So as we get closer to infinity and as we get close to negative infinity, what is our graph going to do? As x goes to infinity, as x gets infinitely large, y goes to c. And as x goes to negative infinity, y also goes to c. So our end behavior is just that horizontal line at c all the way out. Next, let's look at a linear function. We have the line f of x equals x. This is an odd function, so we can see that it is reflected across the line y equals negative x, but basically the diagonal line is where we have a reflection. It is not reflected over the y-axis. The domain, or all possible x values, is negative infinity to infinity, and all possible y values, or the range, is negative infinity to infinity as well. As x goes to infinity, our y also goes to infinity. We get infinitely large. And as x goes to negative infinity, we get infinitely small, and y goes to negative infinity. So we grow in quadrant 1, we grow on the right side, and we fall on the left side in quadrant 3. Next, we have our absolute value function. This function looks like a V on our origin, and the function itself is f of x equals the absolute value of x. This is an even function. Because it is reflected across our y-axis, it's even. Our domain, all possible x values, are negative infinity to infinity. Our range, though, starts at 0 at that endpoint of our function and goes to infinity. So we don't have any negative values, only positive. For our end behavior, as x goes to infinity, as x gets infinitely large, y goes to infinity, it grows in quadrant 1. And as x goes to negative infinity, y also goes to infinity there, so it's growing in quadrant 2. As x increases, y is increasing, and as x decreases, y is still increasing. Next, we have a quadratic function. This is f of x equals x squared, and it's a parabola. This is an even function. It reflects across the y-axis. Our domain is negative infinity to infinity, and our range is 0 to infinity. So we start at 0 and go all the way up to infinity. Our end behavior, as x goes to infinity, y also goes to infinity. And as x goes to negative infinity, y goes to infinity. So this is really similar to our absolute value function. The biggest difference is that our absolute value has straight lines extending, where our quadratic is a curved shape. Next, we have our cubic function. This is f of x equals x to the third. As we can see, this is an odd function because it is not symmetric across the y-axis. It's actually symmetric across a diagonal line. So this is an odd function. The domain is negative infinity to infinity, and the range is also negative infinity to infinity. For our end behavior, as x goes to infinity, y also goes to infinity, and as x goes to negative infinity, y goes to negative infinity as well. So it grows in the first quadrant and it falls in quadrant 3. Now we have our square root function. This is f of x equals the square root of x. This function is neither even nor odd. It is not symmetric here on this graph, so it's not an even or odd function. The domain of this function, all possible x values are 0 to infinity. We can't have a negative under our square root, so we will only deal with positive x values. Since we only have positive values in our function, our range is also 0 to infinity because the smallest value it can be is 0, and it will go all the way to infinity. We'll never have any negative numbers. For our end behavior, as x goes to infinity from 0, y is also going to infinity. Next, we have our cubic root function. F of x equals the cube root of x. This is an odd function. We can't have negative values for our cubic root, so we see that this exists in quadrant 3 as well, and it's not reflect over the y-axis, but over that diagonal line. The domain of our function is negative infinity to infinity, and the range is also negative infinity to infinity. For our end behavior, as x goes to infinity, y also goes to infinity. And as x goes to negative infinity, y also goes to negative infinity. So it grows in quadrant 1 and falls in quadrant 3. Now we have our reciprocal function or our rational function. You can call it either one of these. The function itself is f of x equals 1 over x. This is an odd function. The domain is negative infinity to 0 and 0 to infinity. So it never touches 0, but it gets very, very close to 0, as close as possible. The same is true for our range. Our range is negative infinity to 0 and 0 to infinity. For our reciprocal function, we have two asymptotes. We have an asymptote at x equals 0, so that vertical line at x equals 0, and the horizontal line at y equals 0. For our end behavior, as x goes to infinity, y goes to 0, and as x goes to negative infinity, y also goes to 0. Now we have our rational function squared, so f of x equals 1 over x squared. This one is an even function, so if we're thinking about our rational function, that one was odd. We saw it in quadrant 1 and quadrant 3. Our 1 over x squared is even, so we see it in quadrant 1 and quadrant 2. Our domain is negative infinity to 0 and 0 to infinity, so we never touch 0. And our range is just 0 to infinity. Our function is never negative. It is always a positive value. We have the same asymptotes as our reciprocal function, x equals 0 and y equals 0. For our end behavior, as x goes to infinity, y goes to 0, and as x goes to negative infinity, y still goes to 0. Next, we have a logarithmic function. This is f of x equals log of x. This function is neither even nor odd. Our domain is 0 to infinity. We never touch 0. We start super close to 0 and go all the way to infinity. And our range is negative infinity to infinity. So we can have all the negative values and all positive values as well. We have one asymptote at x equals 0, so that vertical asymptote at x equals 0. And for our end behavior, as x goes to infinity, y goes to infinity. But as x approaches 0 from the right, so as we get closer and closer and closer to 0, moving from right to left, y approaches negative infinity. Now we have our exponential function. F of x equals b to the x, where b is just some value, some number. This function is neither even nor odd. The domain is negative infinity to infinity, and our range is 0 to infinity, so we never have any negative numbers. It starts at 0, it goes all the way to infinity. We have one asymptote at y equals 0. For our end behavior, as x goes to infinity, y also goes to infinity, and as x goes to negative infinity, y goes to 0. Last, we have our greatest integer value function. This is a step function that has just vertical lines. They look like steps on a staircase, where y is an integer and x is all the values across. For example, from 1 to 2, y is the same value. Then from 2 to 3, y is the same value. So that is our greatest integer value function. This function is neither even nor odd. The domain is negative infinity to infinity, and the range is only integers. Y can only be an integer, which is why we denote the range this way. For our end behavior, as x goes to infinity, y also goes to infinity. We get infinitely big. And as x goes to negative infinity, y goes to negative infinity as well. So these are all of our parent functions. We can use these to sketch functions, to do transformations, and to identify what the parent function is of a given function or graph. So let's look at examples of these where we need to identify the parent function given a graph. First, we have this function. This is a V shape. So this is identical to our absolute value function, and the parent function is f of x equals the absolute value of x. Next, we have a line. The parent function of this function is our linear function, or f of x equals x. Here, we have two asymptotes, and it's an odd function, so we have values in what would be quadrant 1 and quadrant 3. So the parent function for this function is f of x equals 1 over x. This is our reciprocal function. This function is just like our square root function, just moved up and to the right. So the parent function for this function is f of x equals the square root of x. This is a parabola, just moved left and up, so we know the parent function for this function is f of x equals x squared. Now we have this function. This is just like our cube root function, just moved to the left and up. So our parent function is f of x equals the cube root of x. Thank you so much for watching. I hope you enjoyed. Comment down below what other topics you'd like for me to review. I upload new videos every Tuesday and every Thursday at 1 p.m. You can also leave me any questions or comments on Instagram and on Facebook at the A+ Tutor. Those are linked below. See you next time!